Okay, so let's go ahead and get started. Section 3.1, we talked about a bunch of different definitions, and one of the things that we talked about were, populations and samples. What we're going to be doing today is looking at samples in a little bit more detail and talking about what is important to think about with regard to samples. Okay, so the whole point of a sample was to tell us something about the population, right? So, if I wanted to do a survey, let's suppose I wanted to know, what percentage of people in Illinois, um, you know, feel that we should, lower income taxes or property taxes or something like that, right? Okay. There's a lot of people in Illinois. Okay. And it would be very time consuming and expensive to survey, millions and millions of people. Okay. So what I could do instead is I could say, well, let me just, talk to say 1,000 people, find out their opinion, and that will give me a good idea for how people in Illinois feel. Okay. But the whole point is for me to know about the population. And what we want to do is make sure that the sample that we take is a good representation of that population. So let's get back to the taxes idea. If I stand outside City Hall where people are walking in to complain about their taxes or get like a reassessment or something like that, that's probably not how everyone in Illinois feels, and I'm probably not going to get a good idea for the opinions of everybody in the state. Okay. Likewise, if I just pick, say, one county that either has really high taxes or really low, property taxes or something like that, okay, again, I'm not going to get the same types of responses if everyone I ask is in this tiny geographical area that I would if I talked to everyone in the whole state. Okay, so we want to make sure that our population is represented well. Okay, now we know that different samples will give us different results, but we don't want to we don't want our sample to mislead us. Okay. Okay, so it's really key that our sample, when we choose our sample, we want it to be as similar to the population as absolutely possible. Okay. So like, here that they're giving you an example. Let's suppose we want to test a new painkiller, right? If I only test a new painkiller on people that are between 18 and 25 and very healthy, that's probably not a good way to determine how effective it is or what the side effects are going to be for everybody that's going to use it, right? Because I've sort of just narrowed in on this tiny segment of the population, and I have other people with different health conditions that I haven't tested it for, and it's not going to let me know what's going on. All right. So let's look at how to collect a sample. And there's lots of different ways. And the thing that we need to realize is that no matter what good method that we use for picking a sample, we're not guaranteed that that's going to end up being representative of the population. And so we can always have problems with our sample. Okay. So there are no guarantees in statistics. But there are some techniques that are going to be better than others, that are going to give us a better chance, or at least a reasonable chance, at having a good representation of the population. Okay. Um, so that's what we're going to talk about here. Just remember, right, the sample may not be representative. Okay. And this is going to be something that's going to come up later on too, when we're coming up with conclusions. We have to account for the fact that sometimes our sample is not a good representation of the population. Okay. Here's an example. You can take a random sample of a group of people that is equally males and females. Okay, so let's suppose that I have a population where there are just as many males and females, and I go and take a sample. It's certainly possible, just by random chance, that everyone I choose is female. Okay, and if that happened, then that wouldn't, if all I'm talking about is gender, that wouldn't be a good representation of my population. Okay, I can see how that we can even randomly picking, we can just miss. All right. Let's look at a couple sampling techniques. The simplest one, the one that we're mostly going to focus on, is something called a simple random sample. Okay, so this is where we pick a sample such that um, every member of the population is equally likely to be chosen. Okay, and in order to do this, we need a list of everyone that's in my population, right? So for example, if I wanted to survey people in Illinois, I don't have a list anywhere that is every resident of Illinois. I don't know who lives in Illinois. That sort of changes, right, over time. Okay. And I don't think that there's any running record anywhere of everyone who's living in the state. So it would be really hard to do a simple random sample of people in Illinois. Okay. Um, if I wanted to survey students at Harper, though, I do have a list of everyone who's a student at Harper. Well, I mean, I don't have it, but it exists somewhere. And, you know, you could go to that list and randomly pick off of that list, and that would give you a simple random sample. Okay, so let's look at what a simple random sample is. A simple random sample of size n is a sample that's selected from a population in a way that ensures that every different possible sample of size n has the same chance of being selected. Okay, or another way to think about that, I think a way that makes a little bit more intuitive sense, is that every individual in the population has the same chance of being selected. Okay, so there's nobody that is more likely to be picked or less likely to be picked in the sample, and that's what we really want. That's our goal with a random sample of any kind. Okay, and there are some easy ways to do that, right? So some basic ways of drawing a random sample is to put all the names in a hat and draw out some names. Okay, and we can kind of do the same thing with something like a random number generator, right? If I was looking at students at Harper College, that's kind of too many names to just put in a hat and draw. I mean, I guess you could do it, but it would be easier just to say, all right, I'm going to assign everyone a number, like maybe your ID number, and I'm going to use a random number generator just to randomly pick people off of that list. Okay. So let's look at example here. One sec. Okay, so let's suppose we're looking at a classroom of students and we want to take a simple random sample, right? So there's more than one way that we could go about doing this, okay? But let's just look at a way that we could go about taking a simple random sample, okay? So one way that we could do that is that we could go around the room and count off people. Okay, so that everyone has a number, okay? And then we could maybe use a random number generator to randomly pick numbers. Yes, I am recording this meeting. Thank you for reminding me. Okay. All right, another way that we could pick randomly from students in a classroom. Okay, maybe I could say, all right, let's pick every third person. Okay, maybe just kind of going in order of the desks or tables. Okay, and then just to make sure that everyone is just as equally likely to be chosen, we don't necessarily start with the first person. We can maybe randomly pick or flip a coin or something like that to see, do we start with the first, second, or third person? Okay. And the idea here is that everyone is equally likely to be chosen, because if I'm randomly starting with the first, second, or third person and I'm picking every third person, okay, I'll have picked like a third of the class, and it's just as likely that you're in, the third, or that you're in the third that's picked as anyone else is. Okay. All right. So these are just two different ways that we could go about picking a random sample from a room. Okay. The key thing, right, that we want to think about with a random sample is that everyone is equally likely to be chosen. And in a situation where we have that, then we have a good chance at our sample being representative of the population. Okay, looking like the population. Okay, let's look at a bad way to choose a random sample. Okay, so let's suppose I want to pick 5 students out of a class of 20. Let's look at some ways that are not random samples. Okay, so one way that I could do that is I could pick the 5 people sitting in front. Okay, because if you're somebody who prefers to sit in the back, you will never be picked for the sample. Okay, so you're not just as likely as anyone else. Or maybe if you have poor eyesight and you always sit in the front so that you can see better, okay, then you will always be picked in a sampling like this. Okay, and again, that's not a random sample. That doesn't make you just as likely as everyone else. Okay, we could also say, what if I pick the 5 tallest people? Okay. Again, it's not the case that everyone is equally likely to be chosen, so that's not a good way to pick a sample, because it's not going to have a good chance at being representative of the population. Now, maybe the question I'm asking has nothing to do with whether people are tall. Maybe that sample turns out to be fine, but I want to have a sampling technique that I can have some confidence in, that I can believe will be representative of the population. And since we don't really have a way to check, right, the whole idea of a sample is that we're not going to ask everyone in the population. So we don't really have a check, so we can't be sure that our population, that our sample is a good representative of the population or not. So we want to make sure that our sampling technique is robust, right? We don't want to use a bad technique and then hope we get lucky and get a good sample anyway. We want to start with a good sampling technique. Okay, so we're going to have a term for this. When you use a sampling technique because it's easy and not because it works well, we call that a convenient sample. Okay, so a convenient sample is any sample where the members of the population are not equally likely to be chosen. Okay, and we call it a convenient sample because hopefully it was convenient because it's not good, right? Um, there's no reason to suspect that it's going to generate a sample that is going to be representative of the population. So any data that we get from that isn't going to be reliable. Okay. So here's an example of a convenient sample. If I want to know about the criminal justice system, and I stand on a street corner near a county courthouse and ask the first 10 people who walk by, okay? Well, the people who walk by are most likely involved with the criminal justice system in some fashion, right? Maybe they're, lawyers who have a lot of confidence in the criminal justice system because that's their job. Or maybe they're people that are either walking to or from a court hearing, okay, and maybe they don't like the criminal justice system because they're on the wrong end of it, okay. These are going to, this is a very obvious example, but it highlights how if you just pick the first 10 people that you see, okay, um, you probably aren't going to get a good representation of everyone's opinion. And most people probably don't feel really strongly one way or another, okay, about a lot of topics, although criminal justice system is one of those hot button topics that I think most people have some opinion on. But if you want to get a representative of the whole population, you want to make sure that you are representing the full spectrum of opinions in the population. Okay. Um, there's certainly times when we could collect information from our entire population. And in that case, what we have, we don't call a sample anymore. What we're going to do is we're going to have a term for that. A census is where we collect information from the entire population. Okay. The one that I think people are most familiar with is in the US, every 10 years, by law, we're required to do a census where we count everyone in the population. Now, during that census, we end up collecting more information, but the main goal is just to count how many people there are. So the piece of information that we're collecting is just, do you exist? Okay. And just to give you some perspective, in order to do this, in order to collect information from the whole population of people in the US, it takes years and years of work. There's years of prep work, and then there's years of actually carrying it out, and it costs billions and billions of dollars. Okay, so if let's say I'm, a company like Target, and I want to know how people feel about the new summer fashions, and I want to collect information from the whole population, obviously it doesn't make sense to spend billions of dollars, right, and years to figure out what's going to be trendy this summer. So what I would want to do instead, obviously, is take a sample, right? Maybe just ask a few hundred or a few thousand people, right? That's easy to do, um, and use that information instead. Okay, so a census is something that we talk about. It's going to be pretty rare unless our population is really small because it's so difficult to find everybody. Okay,